Hello, everyone. Thank you for joining us for the next session of our RAG Deep Dive series, RAGChat, Evaluating RAG Answer Quality. My name's Anna. I'm an event planner for Reactor, joining you from Redmond, Washington. Before we start, I do have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional, and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenter to answer live. Our session is being recorded. It will be available to view on demand within 24 to 48 hours right here on the Microsoft Reactor YouTube channel. With that, I'd love to turn it over to our presenter for today. Pamela, thank you so much for joining us.
Hello. Welcome, everyone, to the RAG Deep Dive series. Today's session about evaluation. And we have the slides available for you so that you can reference them or use them later or reuse, do whatever you'd like with them. My name is Python. My name is Pamela Fox, and I'm a Python cloud advocate, which means I help Python developers be successful with Azure and VS Code and GitHub Copilot and every interaction of Python and Microsoft. Now, for those of you who are new to the series, we are nearing the end of the series. Sad. But it has been a really fun series, and it's all available on YouTube so that you can rewatch at your leisure. So we've got 2 more after this one that you can still register for if you haven't registered for the series yet. But basically, in this series, we are doing a deep dive into our most popular RAG solution. So this is a solution that is in a GitHub repo, so it's entirely open source. It's built on top of Azure OpenAI, Azure AI Search, and can be deployed to either Azure Container Apps or Azure App Service. It starts with basic RAG features, but then it has a ton of optional features that developers have asked for, and sometimes also the developers have contributed themselves. So it's also a community project, and it really shows you all the different aspects of RAG that you might consider using. And so you could either use this repo itself, and that's many developers have done it, thousands and thousands of developers have done it, or in developing your own RAG applications, you can get inspiration from our repo to figure out how to best do it. So in this series, we're exploring all the different aspects of this repo, both to help you use the repo itself, but also to help you with your own RAG code bases. So the code is here, aka.ms/RAGChat. Put that in the chat. And there is also a public demo that you can check out that has the basic features enabled, and that's aka.ms/RAGChat/demo. I've got that open here. The sample data is basically boring company data. It's just an example company and their HR data and company roles and all that stuff. So we can ask about the health insurance and get a response that streams in and answers it according to the documents for this, this pretend company. And we can get citations, and we can look at those citations. We can look at the thought process, and yeah, so there we go. So that's the basic RAG experience, is getting questions and getting answers based off of these documents. In this case, the document's a PDF, but it also supports more than PDF. So it could be a docx, a PPTX, a CSV, a JSON, HTML, all sorts of different formats. And the simplest RAG flow that we use in this repo is we get the question, we use that to search the search index, we send the results and the question to a large language model and get back an answer. We also have more advanced RAG flows as well, but you can just think about this RAG flow and in terms of thinking about how it works and how it gets that answer. So today what we're going to look at is the answer quality, right? We see the answer coming in that comes from the LLM. How do we determine whether an answer is high quality, and how do we evaluate quality as a whole, and how do we improve quality? So the first question is, what does it mean for an answer to be high quality? The first thing is that they should be clear and understandable. Now, the good thing about LLMs is that, at least if you're using them powerful models like the GPT models, GPT 3.5 and up, the answers are pretty much always going to be clear and understandable. They're very good at producing fluent language. They're very good at speaking our language, right? So that's pretty much a given when we're using powerful models, is that they're going to be clear and understandable. More interesting is, are they correct relative to that knowledge base, right? So a good example would be the question we have here, like, what does a product manager do? We're not asking what does any product manager do across the whole world. We're saying, what is a product manager for this company, according to this company's data? What does that product manager do? So we're asking the LM to constrain itself to our company's data. And we want a good answer is one that is entirely constrained to that data and doesn't bring in any outside knowledge that's in the weights of the LLM. So this looks like an easy question, but in some ways it's actually the harder question, because an LLM could definitely answer this question, what does a product manager do, without having any information at all, right? And so this is the kind of question that it would be the most tempted to be incorrect on, because it's got so much outside influence in its training weights. So we want to know, are these answers correct? And then finally, we want to know, are the answers formatted in the desired manner, right? So do they use Markdown versus HTML? Are they using paragraphs or bullet points, however we've asked? And then most importantly, for our application, for this RAG application where we want to have citations, is, do they provide citations in the right format? So the only example here that actually provides it in the right format is the final one, where you can actually see the citation has square brackets and then the document name and then hash page equals 3 square bracket. That is the exact citation format that we want. And we need it to be following that format so that the front end can then pull out that citation, render it as a citation, and make that a clickable link that the user can then use to open up that PDF and dive more into that document. So those are the two most important things to me, is getting correct answers for the knowledge base and getting the right formatting, especially for citations. Now, for your own applications, you might have other aspects of quality that you're most interested in, but especially for this RAG application, that is what we care about the most. Now, the hard thing about answer quality for RAGChat applications is there's so many factors that affect the quality, because there's so many steps. And this is only showing the simplified RAG flow, and we're usually using a more multi-step RAG flow. But even in the simplified RAG flow, right, we have all these factors that go into the search step, right? So what search engine we're using? Are we using hybrid search or only vector search? Are we using the re-ranker? Like, are we doing any sort of query cleanup? Or any query rewriting? How did we ingest our data? How big are the chunks that we ingested? Which embedding model did we use? What boundary did we use when ingesting? How many results do we return from the search? Like, just so many options just on the data ingested and search step right there. And then we haven't even gotten to the LM, right? So then we get to the LM. With the LM, like, well, one big thing is, what actual model is it, right? Is it GB3.5 or GB4? That makes a huge difference. But then obviously there's the prompt that you're using, what language you're using, whether English or a different language, whether you're passing message history, what temperature you pick, what max tokens you pick, like all these parameters on the LM side as well. So that can be a bit overwhelming to look at all of the possible things that could affect quality and try and figure out, like, what could you do to actually improve quality. So first, what you could do is experiment manually with quality factors. So in this repo, we do have this developer settings here. And in this developer settings, you can override quite a lot of the things that would be most important for affecting the end results, right? So you could override the entire system prompt. You could change the temperature. We default to 0.3, but you could try 0.2, 0.4. You can go crazy, go 0.7. But usually 0.3 is a good temperature for RAG. You could set the seed. The seed is good for evaluation, because what happens is, if you set the seed, and this only works with OpenAI models so far, but if you set the seed, then it's like setting the seed for a random number generator. It makes it not really that random, right? So the idea with setting the seeds is that if everything else remains constant, you should get the same result. Now, I will say you still even get variability even if you set the seed, but you get way less variability. So if you are doing any sort of evaluation of quality, you really want to set that seed so that at least that aspect stays constant. and then you can tweak other things, right? Because that's the thing about LLMs, they're non-deterministic. One of the ways that we can make them more deterministic for the OpenAI models is to set the seed, so that then we can, change other things while keeping that seed constant and only get the effect of the other things for the most part. So here we go. We set the seed. There's all these things related to the search, right? Whether we're going to have a threshold for score, how many search results we want to get. Usually we do 3, but you could imagine situations where you might want like up to 10. What sort of search mode we're using. We always recommend hybrid plus ranker, but you could try other ones as well. So there's lots of different options there. So that's one thing you could do, is you could play with those settings there and see how it affects the answers that you're getting, especially if you're getting an answer that you don't like as much. However, that can only take you so far, right? If you do some, manual evaluation, you try it out, like I can try here. So let's change the temperature. Let's go high on the temperature. Now, usually you should only change one thing at a time, right? So let's go high on the temperature and try what does a product manager do and see. And here, like, actually the answer still looked pretty okay, right? It's more useful when you have a question that you're otherwise getting a bad answer for, and you like kind of tweak things to say like, oh, well, how could I get a better answer, right? That's where this manual experimentation can be the most helpful. But here's the thing about manual experimentation is that it can only take you so far, because you might find some new set of parameters that gets you a better answer for one question, but that new set of parameters may not get you the best answer across a bunch of questions. And that's a big caution I want to give you, is like, don't get too excited by improvements in manual tweaking. Like, use them as an idea for things you can change to improve overall quality. But you really have to keep in mind is that you want to get overall quality across a large number of questions, and something that improves it for a couple of your sample questions isn't necessarily going to improve it across the board for a huge number of questions. And sometimes it'll make it worse. So what we really want to do is automated evaluation, bulk evaluation on lots of questions, to really see the effect of changes on lots of questions. And I'm just checking the chat. I do see there's some questions in the chat. I think some of these are best for the end. So please bring them up back at the end if we haven't covered them yet. So now let's talk about automated evaluation. There's a bunch of evaluation frameworks out there. And, a lot of them are like open source packages. So Microsoft has a few packages, right? So it's got azure-ai-evaluation for Python. And then there's a related one for .NET called extensions.ai data evaluation. So we'll be looking at azure-ai-evaluation today so that you can see how that works. It does have an optional cloud component. So a lot of these evaluation frameworks are open source ones that you can run, you can run locally as long as you've got some sort of like, LLM that you can run it with. But then a lot of them now have cloud components where you can like run evaluations in the cloud. You can store your results in the cloud, because a lot of people have turned their open source packages into startups, right? And startups need to, charge for something, right? Like they need to have a service that they're offering, like a cloud service. So that's the kind of general trend we see in these evaluation frameworks, is starting off as open source packages that you run locally, and then they start to have cloud components. There's another one called RAGAS, and we actually are going to use RAGAS today as well. So you'll see at least part of it. There's one called DeepEval. That's in Python. And they also have an optional cloud component now. There's Langsmith from LangChain. And I think maybe its cloud component is required. I actually haven't used it yet. So maybe someone else can say if they've used Langsmith, put it in the chat. There's one called PromptFoo for JavaScript, and that also now has an optional cloud component from what I could tell. See the question from Robbie, no evaluation frameworks for Java or Rust. That's a good question. I did ask, I asked a few hours ago to see if folks knew about other packages. I didn't hear about ones for Java or Rust, but if I hear anything more, well, I guess I'll update the slide, or I don't know. I'll put it in the comments or something. So yeah, because ideally we would have frameworks for all the languages. Of course, another option is that you take a Python framework and then you wrap it in your favorite language, and usually usually there's ways of doing that across different languages. So let's look at the Azure AI Evaluation SDK so you can get a feel for how at least that SDK works, and somewhat similar to other ones, right? So we can install the package Azure AI Evaluation. And then the package comes with a bunch of built-in evaluators. These are what's called like a GPT evaluator. So it literally is going to use an OpenAI model to do its evaluation. Typically, you want to use like a really good model. So I use either GPT-4o or GPT-4 Turbo. Those are the only two that I'm currently comfortable using as an evaluator. There's some interesting research there about there's some folks who think that you should always use more powerful models to evaluate your flows, but then there's other people who argue that judging is easier than generating, so you can use less powerful models. I still prefer to use more powerful models when I'm evaluating my flows. So in this example, so we create a groundedness evaluator, and then we pass in a answer from our application, and then the sources, and then this evaluator tries to determine like, oh, okay, was this a good answer? So let me actually show you the full code for that. We'll post this notebook in the chat so you can take a look and see what it looks like, right? So first we need to set up a connection to OpenAI. So this is all just code setting up a connection to OpenAI. And then also setting up connection to Azure Search, because this example is doing a RAG on Azure Search. Then, this is basically similar to what our application would do. Like we get a user question, like what does a product manager do? We use that to search our search index. We get back a bunch of sources and we say, hey, LLM, please answer based off the sources. And we get back the response. And this looks a lot like the responses that I was showing all of you, right? A product manager, blah, blah, blah. And then it's got those citations here. So now we've got the user question, we've got the response, we've got the sources, which are the document chunks that came from the search index. And so now we can evaluate. So this, sets up the connection to Azure OpenAI with our powerful like GPT-4 deployment. And this one runs both a relevance evaluator and a groundedness evaluator. The relevance evaluator takes the query, the response, and the context. And groundedness takes just the response and the context. And then we get back scores. So each of them gives back a score between 1 to 5, 5 being the best, 1 being the worst. And it also gives back a reason. So if you want to dig more into it, you can look at the reason and say, oh, okay, that's why the LLM thought that it deserved a 5 or deserved a 4. And so that's generally what the results look like. Now you can even dig in, and I was looking at it earlier. Let me see if I can bring it up. Azure Python SDK, like you can actually look at, what is this, like what does that actually LLM call look like? So you can go into the code base, and I was doing this morning even, and look at the evaluator, and this one is groundedness without query. Okay, and it uses a prompty file. We've talked about prompty in this series. So prompty is a way of structuring prompts. This is a really long URL. I don't know if it's going to let me post it. Let's see. It was too long of a URL. Let me change domain. Here we go. All right. I think it'll let me post this one. There we go. Okay. But you can actually see. So basically, we're literally sending a message to the LLM and saying, hey, your job is to evaluate this response. You're going to be given, a context and response. And here's a bunch of examples of ones that would get 1, ones that would get 2, answers that would get 4, answers that would get 5. Then we give it the context and the response. And then it's instructed to give the score as well as an explanation. So that's what it's literally doing. So you can imagine you can use this sort of prompt with any sort of LLM and get back the response. Now the SDK has a bunch of these evaluators built in, and it has folks that are constantly working on them and improving them. And it makes it easy to, extract the scores and the reasons back out. But that's generally what it means to be using an LLM as a judge. So as I was saying, this SDK does have a bunch of built-in evaluators, and they generally take some combination of query, context, response, and ground truth. So the query is the user's question. So like, what does a product manager do? That's the query. The context are the sources that come back from the search index. Those are like chunks of documents that potentially answer that question. The response is the actual response from the current application. And then the ground truth is what we think the best response is. So the groundedness evaluator just looks at response and context and says whether the response is grounded in that particular context. Then we have a bunch that look at response and query, like relevance, coherence, and fluency, and they consider them together. And there's a similarity evaluator that tries to say how similar to the response and the ground truth are to each other. Now, I actually only use groundedness and relevance of these. I don't use coherence and fluency because I really think the models are just always going to score 5 out on those from what I've seen, because these models are very good at speaking our language. Similarity, it's similarity. I just still think it's hard for to gauge similarity. There's other methods of gauging similarity as well that don't use a GPT. So there's something called F1 score. There's one other one as well. But I haven't found it to be a useful metric. But if any of you have been using a similarity type metric, I'm curious which ones have been useful for you. So for me, the ones that have the most signal have been groundedness and relevance. So that's where I, spend my time. Because remember, all of these calls are going to be a call to an LLM. So we don't want to make a bunch of calls to LLMs if we're not getting useful data out of it. So after I've run like dozens and dozens of evaluations, and based on that, I've been like, all right, the ones where I'm really getting high signal is groundedness and relevance. And so those are the ones I'm going to stick with. Now, with the Azure AI Evaluation SDK, they do have a way that you can do bulk evaluation. So there's an evaluate function where you pass in like a JSON lines that has your data in it. You say which evaluators you want to use. You could also specify custom evaluators. You pass in an Azure AI project, which is a project in Azure AI Foundry. And then you say where you want your output to go. So that's an option for doing bulk evaluation. I actually have my own way of doing bulk evaluation with the Azure AI Evaluation SDK. So you can think of this SDK as both having like low-level evaluators and also having higher level tools as well. And you can kind of decide whether how you're gonna put together these options. Now, the cool thing is if you do use this bulk evaluate and you specify an AI project, then you get the results in Azure AI Foundry. So that is certainly something to consider if you are a big user of Azure AI Foundry. Like if you have people that need to be able to easily log into the Foundry and, and see evaluation results, that might be a reason to use this evaluate flow with the AI project. But you can also get the results locally, and you could save them locally. You could save them into repo. You can just display them in GitHub Actions. That's actually what I'll be showing today because that's what I do most of the time. All right, so now we've talked kind of generically about the Azure AI Evaluation SDK. So what I want to show now is how we can use that SDK as well as other ones in order to do like a whole end-to-end evaluation flow for our RAGChat solution. So our general steps are going to be first to generate ground truth data, then to evaluate that with different parameters, changing just one of them at a time, and then to compare the metrics and answers across evaluations so we can decide what changes to make. We have docs for doing that in the repo. And I will say I did just add this doc to the repo today. So if you do want evaluation and you checked out the repo before today, you should pull in the latest changes. And because I'm trying to make evaluation easier and easier. So this doc is new and some other things are new as well. So the first step is to generate ground truth data. So the ground truth data is the ideal answer for a question. Now, ideally, we would actually have humans writing the ideal answer for a question, right? Like a human that knew the data really, really well, right? They would presumably be able to write a really good answer for it. However, that takes a lot of human labor to be writing ideal answers for questions, and we may not have the ability to have humans do all that work. So what a lot of people do is they synthetically generate ground truth data and then manually curate it. you should at least have the manual curation stage, just to have a human go through and say, oh, that's good, that's not good, that's good, that's good, right? And they can even do some additional editing, right? So I have a script that does that in the repo. So it's we call, generate ground truth, and we say how many questions we want. I usually recommend 200 as a good number, but you could also start with a smaller number of questions. If you're just playing, just experimenting to see what sort of questions you get out of it, because this is a process that takes time. The general approach here is that we are using Azure AI Search to bring back all our documents. So we're going to look at all of our original documents in AI Search. We're going to send those to RAGAS because RAGAS has a ground truth data generator. And RAGAS is going to then use OpenAI plus its own logic in order to come up with however many QA pairs we want of ground truth. And then we can have the human review it. Now, there's other approaches as well, right? If you have, if you're building like a customer support system, you might have existing help desk tickets, or maybe it's GitHub issues, support emails, questions from beta testers, like lots of places that you could get good examples of questions with answers for the use case that you're working on. The best questions would be ones that are close to what users would ask. So if you already know what users are going to ask, you should use that data and, create the ground truth based off of that. So let's look at how RAGAS actually does this. And you can look at the RAGAS docs to get more information. These diagrams are from the RAGAS docs. I feel like I'm saying it wrong too. Maybe RAGAS? Okay, I don't know. RAGAS. Okay. Anyway, so the first thing that RAGAS does is it builds a knowledge graph based off the documents, and this is really cool. So it takes all the documents we get from AI search, and it tries to identify themes and topics and uses that to make this knowledge graph of the themes and topics. And I even have that knowledge graph saved, because you can also save that knowledge graph as an intermediary step. So let me open that so you can see, because it's cool, right? So here's a particular node which has the content. It has a summary, so they also summarize each of the document chunks. And then for each of them, you see themes. So these are the themes that it identified, and then also entities. So that's basically, so for each of them, you've got the actual content, you've got a summary, you have an embedding in the summary, you've got the themes, and you've got the entities. So that's what's in the knowledge graph, and then you've got the nodes connected to each other. So we build that knowledge graph using RAGAS, and then we tell RAGAS, all right, here's the knowledge graph. So we pass this knowledge graph off to RAGAS and say, all right, now we want you to generate a bunch of ground truth. And what RAGAS does is it comes up with different scenarios. So it'll be like, okay, there's a scenario of a customer, there's a scenario of an employee, right? So it'll come up with various scenarios based off the, kind of topics it sees. And then it also comes up with different question styles. So they'll have poor grammar questions, which are legitimate questions that you'll get, misspelled queries, short questions, long queries. So it has all these ideas of different types of questions that are common to get in a RAG. And it will create all those scenarios and questions, and then just start generating examples. So here's the actual ground truth that I got out of RAGAS. Let me format this so you can see. Oh no, I'm just gonna word wrap it. Word wrap. Okay. So here you can see, right, these are the questions that it came up with, and you can see they kind of vary in what kind of spelling and capitalization they use. Let me find one. This one has a typo in it here. Yeah, and it's pretty cool. I think it did a really nice job. Now there's definitely some I would want to curate and remove. But that's true, whenever you're generating ground truth data synthetically, is some questions will just not sound like questions that your users would ask. And so you'd be like, that's, I'm going to remove that question, right? And this should answer Greg's question. So this is the format that I store the ground truth in. I store the question and I store the truth. I'll show the actual code as well. This is in generategroundtruth.py. So you can see that, we pull, first we pull things from Azure AI Search, right? So we get all of our search documents. Then we create the knowledge graph with them. Then we apply transforms, which is doing like the entity and theme extraction. And then we can save that knowledge graph locally so that we can reuse that in the future to speed up this process if we want to do another generation. And then we say, okay, now you're going to generate based off that knowledge graph, and it'll come up with the scenarios. You could also specify your own scenarios if you wanted to override the scenarios. So there's various options that you can use to override it. So it worked pretty well. You could also just use an LLM to generate ground truth. If you pass your LLM your documents and say, hey, LLM, please come up with a bunch of question answers. You could use structured outputs, right? The goal is to have questions and answers where the answers are based off your actual original documents, but also where the answers look like the kind of answers you want from your app. That's your goal. However you get to your goal, it doesn't matter. Just as long as you end up with having a certain amount of ground truth data that you can use. All right. So now that we have that, now we can actually run evaluations. So let's see if I can run one. The thing about this whole process is that it's generally quite slow. Like that RAGAS process for generation takes a few hours because making that knowledge graph, maybe an hour, making that knowledge graph is pretty intensive. But I could do, let me see, I can limit the number of questions so that it can go more quickly, so that you can kind of see what the process is like. We'll see if it'll run. But basically what this is going to do, it's going to take that ground truth, which we just saw, send that to the running app. Oh, which is why this is not working right now, because the app's not running. Let me run the app. So you can either have it go against a local endpoint, which is what I'm going to do right now, or you can have it go against a deployed endpoint. So I could do either. Could also just have it go against a deployed input, and that's just in. So we have like this config where we can say like, okay, we're gonna do. All right, so this says go against local, but I could also have it go against that one that I shared in the chat. Let me get that URL, RAGChat demo. Okay. All right, so we could evaluate this. So we can evaluate deployed, we can evaluate local. Evaluating local is nice if you have any sort of, like, if your app's in a VNet, or if it's got user log in it, then it's going to be harder to evaluate the deployed version. So I usually like to evaluate the local version, and also don't have to have that latency of going out to the network, right? All right, so then we've got there. Oh, actually, I want to change this too. Okay. Example. Okay. All right, let's see if I can evaluate it here. So here you can see I told it only to evaluate 2 questions, just so I can do a quick one to show you. All right, so first it makes sure that the app is running, then it makes sure that the GPT is running. So we've got everything set up. Then it starts the evaluation. And for each of the questions it sees there, it's going to send that to the app, get the response, and then it's going to measure these metrics here. So we've got the groundedness and relevance. Those are the 2 built-in ones that we looked at already. Then we've got some custom ones here. So we've got answer length, which is how many characters long the answer is. We've got latency, which is how long it took. And then we've got citations matched and any citation. So any citation is whether it had any sort of square brackets in there at all, because we want all of our responses that have a citation. And then citations matched is whether the citations in the app's response matched the citations in the ground truth. Because ideally, the citations should be the same across them, or at least very, very similar. And then we get back results where it says like, okay, well, here's the results. We sent these 2 questions here, and we got back this answer, and this was the ground truth, and this was the context. And then here's all of our scores. So we got groundedness, we got relevance, we got citation match, answered length, right? So this is how it stores the answers. And we can also look at the summary for the high level statistics, and that's stored as well. So that's generally the evaluation process. That was only on 2 questions, so I'm going to delete it since it's not that useful to only evaluate 2 questions. But that gives you an idea for the general approach of how this evaluation script works, right? So we take each question from the ground truth, we send that question to the running app, and we get back the response. And now we've got the ground truth answer, we've got the actual AMP answer, and we can calculate our custom code metrics, like length and latency and citations matched. We can also send it to the azure-ai-evaluation SDK in order to calculate GPT metrics like groundedness and relevance. And then we have all those stored so that we can look at them afterwards. And now we can look at the results. So let's go ahead and look at the results, and then that should clarify how these scores work. So I see a question about that. So we're gonna say, like, okay, we want to see the results across the runs. Actually, I'll show you one in particular, right? So let's look at baseline. So I always have a baseline, which is the current status of the repo, right? So we look at baseline, you can see that GPT groundedness has a pass count of 49. So we consider passing to be a 4 or a 5. We're saying that if you get a 4 or 5, you're passing. That's good enough. So here we see a pass rate of 0.98. So that means 98% of these, 49 out of 50, because here I'm doing 50. So 49 out of 50 got either a 4 or a 5. And then I also have the mean rating, because that can be interesting too, which is just the average of all the scores, right? But we generally consider 4 or 5 to be passing. We have the same thing for the other GPT metric, looking at pass rate and mean rating. And then answer length, that's literally the number of characters. So we can see the average number of characters. We can also see the mean and the max just to get an idea of the distribution. Latency, that's just a normal average with min and max. This is the number of seconds. This is latency till last token, like latency of the entire call, not time to first token. So do keep that in mind, because a longer response is going to have longer latency. Citations matched, here it says, there were 22 out of 50. So 45% of them had citations that matched the ground truth. It says 100% of them had any citation at all. So that meant like lots of them had citations, but not necessarily the same citation as ground truth. And sometimes that's fine, because sometimes it's like, well, it decided to cite a slightly different page, but it's roughly similar. But I still find these to be really interesting to see how many are matching citations. And then it's just how many questions it evaluated total. So that's how we can look at each of the stats. And then we can compare this across runs. So here I've got 2 runs. I've got the baseline, and the baseline is what's default in the repo right now. And that's using GPT-3.5 Turbo as the app model that the actual app is using to answer questions. And then I've got this run called GPT-4o Mini. And that's where I changed the repo to use GPT-4o Mini as the app answering instead, because I'm trying to see, can we safely upgrade to GPT-4o Mini? And will we have the same quality for GPT-4o Mini versus GPT-3.5? And will be any sort of unexpected changes? So this is a classic situation where I want to use evaluations, because I'm changing the model, and I want to know, is it okay to change the model? Will users see a difference in the quality if I change the model? So here what we can see is that they have the same pass rate. So that's good. The mean rating was actually slightly higher for baseline. Okay, interesting. For relevance, we see that actually baseline was slightly higher, but then the mean rating for GPT-4o Mini was higher in that case, right? So it's kind of like a tie here for groundedness and relevance. So there's nothing particularly concerning here because the numbers are so close. And remember, I'm only evaluating on 50 question answer pairs right now. So ideally, I would increase that to 200 in the future to get a little more data. And then we can look at the rest of these, right? So let's look at so citation rate was the same, 100%. However, GPT-4o Mini is matching 53% of the citations versus 45%. So that to me sounds like a good win. Now, what's really interesting is answer length. The baseline has average number of characters of 667, while GPT-4o Mini has average number of characters of 934. That's actually a big difference in answer length. And remember, more answers means a longer answer means, well, first, it takes longer to get the answer because we stream it in. Two, it's going to cost more money. So this is what gives me pause. It's like, do I feel comfortable upgrading a GPT-4o Mini, which seems to be either equal or better in quality, if it means that there's going to be increased token count and, increased cost because of that, increased latency. So then I might say to myself, well, why is it giving longer answers? Is it being unnecessarily verbose, or is it giving longer answers because longer answers are actually better? So the next step that I do is that I actually look at I compare my runs. I compare the actual answers. Because, when you can look at the metrics and be like, oh, interesting, that metric is different. But if you don't know why, it can be hard to know, how to think about those metrics. So here I'm going to use my diff tool, which is another CLI. And it brings in answers across 2 runs to make it easy for me to compare one to the other. So here we can see baseline versus GPT-4o Mini. And you can see in this example that, the length of GPT-4o Mini is a lot longer. So I started looking through these to try and determine why was it longer? And one thing I noticed that GPT-4o Mini is using a lot more lists, like numbered lists and bulleted lists. And I think sometimes, even though it makes the answer longer, I think it often has a more readable answer because of the use of lists, right? So for this example, does Contoso cover gender affirming care? So this one is just a couple sentences. This one is longer, but it uses bullets with bolding. And I feel like even though this is technically a longer answer, it might be a better answer, like a more clear, easier to follow answer because of the formatting. And similar to this one, right? They cover really similar content, but this one decided to use a list. So it's really, really interesting to compare across, across different runs and see what's actually differing across them. And what you really want to do is have somebody who has domain expertise reading through these answers and going like, yeah, that one is actually better and accurate, right? Like it's great when we can get all these stats, but it's even better to have a human that goes through these and says like, okay, yeah, good, worse, right? And kind of get a feel for, does this generally look like it's a better experience for the user? Okay, so now we've gone through it, and now we've got a lot of data that we can use to try and decide like, do we want to improve things? Now, what we could do is say like, well, GPT-4o Mini generally looks better, but it's longer. Maybe we should change the prompt, right? So in that case, I would go into the prompt, and actually, I already even made a change here where I said, I was trying to get more specific. I said only 2 to 3 sentences. This is a change I just made right before. So I could run a new evaluation. It's like, okay, GPT-4o Mini with this new prompt, how does that compare? Which output do we like the most? All right, so we've looked at those answers, and we can keep tweaking parameters. Remember, we try to only change one thing at a time, even though it does take time to run these things. But LLMs are already so hard to reason about that when you're doing evaluations, it really helps if you've only changed one thing. Now, I saw a question about GitHub Actions. Great question. So we could run evaluations in GitHub Actions. I did get that working just before the stream started, so I can now show you that. So that's exciting. Let me open that PR. It's just running on my fork of the repo. So I haven't merged this into main yet. I'll send it out after the stream. But what you can see is that I typed /evaluate, And the reason I do this is because here's the thing: evaluations are expensive. They take time, they take money. You don't want to be running evaluations on every single push to a PR, like of anything on your code base, right? You should only be running evaluations if something has changed substantially, right? So maybe a prompt changed, a default, setting change, like a temperature. That's when you want to run evaluations, in my opinion, because they are a costly and time-taking thing to run. But in the case where, we have changed something, like in this PR here, the first thing I changed, first I made just a really silly change. And then after that, I made a more major change here. So the first evaluate was actually just on the very silly change because I was just testing this. And so here we can see evaluation results, and we see baseline, we see GPT-4o mini, and then we see this PR number 5, right? And so we can see like, okay, here's the ratings, here's our answer length. We can see all those. We can also check the workflow run. And in the workflow run, I've actually output the answers across everything so that you can just go through and easily compare, this PR to the baseline and the ground truth. And in this case, because I changed so little, the answers really didn't change much at all. But then I changed the prompt more significantly. And let's see, it looks like it might still be evaluating, or maybe I broke it. So we'll find out. Oh, here we go. Yeah, I broke it. Okay. What did I mess up? Interesting. Okay. I don't know if that's it. All right. So I'll debug that afterwards, but I can show you, let's see, an example from another RAG repo where I did evaluations. Here we go. So this was a repo that I put together for GitHub Universe, and I actually had the GitHub Universe attendees try to change the prompts themselves, and I ran the evaluations on all their prompts. And and so they do some like answer only in haiku. And then we get back responses here. You can see that the groundedness went way down. The relevance went way down. And we can see I had some other metrics here, like F1 score. So that's the kind of idea of what you'd imagine. Like somebody sends something to your PR that changes something significant. You run the evaluation flow, and then you get back the results. All right, so that's GitHub Actions. I will be sending that as a feature for the repo after this, but you can also just look at how I've done it across several repos to figure out how to do it in your own. But I do think that's a nice flow, because then it might be hard for people to set up the evaluation environment for whatever reason. But if you're able to do it in CI, then you get a PR in that changes something. You say, oh, I really want to evaluate this. Now, all of what I've shown you is actually using another repo that I have called AI RAGChat Evaluator. It's basically like a wrapper repo on top of the Azure AI Evaluation SDK, just to make it easier for me to do these things across multiple RAG repos. But it's all open source, and my idea is that I think people want similar workflows. So what I encourage you to do is, like, if the tools are useful to you, like these CLI tools, these are built with Python with the textual library. If they seem useful to you, you can fork this repo and then just run with it. These also this includes the GitHub Action output as well, because for GitHub Actions I needed to output everything as Markdown. So instead of having a CLI, this outputs as Markdown, and then I can use it in Actions. So there's a bunch of code inside this repo that makes the CLI tools, makes the the output for GitHub Actions, and just makes it easier for me to do similar evaluation flows across multiple RAG repos. And so the idea is that maybe it makes it easy for all of you as well. All right. Okay. So that's basically what we have for the RAGChat repo. Let's talk about some overall best practices for evaluation. And these are just lessons learned from all the evaluations that I've run on the RAG repos, right? So we've already talked about this. If it works better for 3 questions, it doesn't always work better for 200 questions. So don't over-index on your sample questions. Any parameters that you think could be improved, make sure you run a bulk evaluation. Evaluate data that you know. Remember that LLMs can sound really convincing in their wrong answers. So I actually usually also evaluate other indexes besides the sample index. So I have another index, which is like all a RAG on my blog. I have like RAG on my garden plants, like stuff that I know where I can look at the answers and be like, oh, okay, yeah, that it looks nice, but actually that's not the best answer. So you should either be evaluating data that you know, or you should be involving a human that has domain expertise that can take a look at your answers and, and bring their expertise to it. And generally, I wouldn't trust absolute metrics for GPT evaluations, right? When we see a 5 for groundedness or a 5 for relevance, it doesn't necessarily mean it actually really is definitely truly grounded, because these, the LLMs can also be persuaded and that something is grounded when it really isn't. So I never trust the absolutes like the 5s, but I do look at differences in changes, right? So if I see like a big change in groundedness or a big change in relevance, then I am going to pay attention to that. But what I'm saying is if you get 100% 5s, it doesn't mean that you have a perfect RAG application. It means that it at least did a good job of earning 5s from the judge, but it doesn't mean that it's, exactly perfect. That's just how it works these days. And then remember that LLMs are non-deterministic, right? So do everything you can to, make them more deterministic when you're doing evaluations, like setting the seed, or if you can't set the seed, like run the same parameters multiple times and, look at the results across them. But just always keep that in mind so that you don't accidentally get persuaded that something is better just because you happen to see a probabilistically different result on the next run. Now, people often ask, like, what actually does make a change to evaluation results? And I have some idea based on all the evaluations I've run on this RAG repo. So generally, you want good retrieval. So much comes down to good retrieval from the search index. So if you get good complete retrieval, like if it has all the answers it needs to answer the question, it usually does a good job. If it gets anything irrelevant or distracting, it can easily give the wrong results. It's very easily distracted. So that's why I always recommend using like a search score threshold so that you throw out any results that are distracting, right? You really don't want to give it any reason to go awry. And generally, the model choice makes a huge difference. Like I've tried tons of different prompt engineering, different prompts, and sometimes the prompt changes will affect something, but most of the time what really moves the needle is going from like GPT-3.5 Turbo to GPT-4o Mini, right? Or GPT-4 to GPT-4.4.0, like all those changes, those can make a big difference, and more so than little prompt tweaks. What doesn't move the needle is fluff. I call it fluff in prompts. So stuff like you're a helpful assistant. I really don't think you actually have to tell a LLM to be a helpful assistant, because at least the LLMs that we're using, they were trained to be helpful assistants. So it's kind of redundant to tell them to be a helpful assistant. Like I've done experiments where I've like removed as much as possible from the prompt and still gotten really good results, right? So I try to focus the prompt on just what's needed for like instruction, like the syntax of the result, like everything, I want most of everything in the prompt to be about like how to format the citations, how to look at the sources, that sort of stuff. And I remove stuff about like personality, tone, role, that sort of thing, just because it doesn't seem to have that big an effect from what I've seen in my evaluations. Another thing to keep in mind is that here all of my evaluations were about questions that the app should know. But what about the app being able to say it doesn't know? Because when we're doing a RAG app, a lot of times we want that RAG app to only answer stuff in its domain and to refuse to answer stuff that's outside the domain, right? I did, this was something that was important because we get feedback from people who are like, wait, it's answering these questions it shouldn't answer. Like this is outside the domain. So I wrote some tools to try and make it easier to evaluate this. So first I have a tool that tries to generate a bunch of questions that it shouldn't know. So questions like who painted the Mona Lisa, or like nonsense questions like why is this guy talking? I don't know, something, right? So there's like various categories of questions that it should know the answer to. Like some of them are like popular culture ones that aren't in your domain, but others of them are just nonsense questions, right? And then I have a metric, this GPT metric called don't knowness, which is just like, evaluate whether this, whether it successfully said, I don't know. And I can, run that against it. And then I can look at the results across that run. So this is a whole separate evaluation flow that I do. And there I did actually try lots of different prompt tweaking, but in the end, the only thing that improved things was going from GPT-3.5 to GPT-4. So that's another thing to keep in mind, is that you want to both evaluate how the app should respond when it does know something, but also keep in mind how the app should respond if it doesn't know something, and whether that's important to you. For some people, you might not mind if it pulls from its weights, but for other people, that might be important. All right, so now let's talk about some things you might consider for when you have a production app and how to improve and evaluate it. And these aren't features that are necessarily in the repo yet, but things that come up a lot, right? So when you're developing your RAG app, right, we've built it, we've done evaluations on what's in our code base, and then we want to productionize it. So when we productionize it, then we start having users. And that once we start having that opens the doors for other forms of evaluation and improvement. So the first thing we might want to consider is logging answers. So we do actually log answers now in the chat repo if you're using chat history. But once you log answers, then you could sample those questions into your ground truth data set to make sure that your ground truth data actually reflects what your users are asking. And you might also want to improve the answer if you didn't give a good answer to the user, right? This helps you avoid what's called drift, right? A big risk is that your ground truth data set doesn't actually reflect what your users are asking. And the best way to get around that is to actually get questions from your users. Now, you do want to be really careful about privacy and PII. So, consider whatever your privacy policy is, maybe only have people opt into sharing their questions. You can also use a service to remove PII before sampling, but definitely keep in mind privacy when you're considering bringing user questions into your ground truth data set, right? You could also add feedback buttons. We don't yet have in the repo, although there was a PR a few weeks ago that added them. But the idea here is that you've got thumbs up and thumbs down buttons, and you can monitor those thumbs up and thumbs down over time to see how things are, generally trending. You could set alerts if you suddenly get a huge number of thumbs down. You could specifically debug the answers that got rated thumbs down. That feels pretty good to me from a kind of privacy perspective, because a lot of times if you thumbs down, you can ask, you can even ask are you okay with sharing this response, right? And then if you're doing A/B tests, you could use thumbs up as the goal for that A/B test. Like if you get more thumbs up, then this is a good test. You can also run online evaluations. This is something that some people will do where usually it'll be sampling questions that come in, and every 5 or every 10, they'll run some evaluations to make sure that they're still seeing good groundedness and good relevance. And so you could run any metric that doesn't require ground truth. So you can run actually quite a few of the GPT metrics. You just can't run any of the ones that require ground truth because you won't have ground truth. But you could still do that. You can do it every so often, sample a question answer, run a GPT on it, and just monitor that over time. Now, if you are interested in conducting A/B experiments, we're actually developing a tool for that, and we'll give you the ACA if you want to get into the private preview for that. There's a team working on this to make it easier to run A/B experiments specifically with LLMs. And yeah, potentially in the future, maybe the LLM could improve itself. I think I saw that mentioned in the chat. So if that's something that's interesting to you, do sign up for that private preview so you can try it out and see if this is useful. Okay, so that's the end of the slides. I know there were lots of good questions, and we just had a lot today. So let me see what questions I can still answer here. Okay, there's a question from Rajesh. Any thoughts on evaluating the fine tuning of models? Yeah, that's a good question. I haven't done fine tuning, but my colleague Cedric has done it in his RAF distillation repo, and I think he's got evals in it, actually. He does do evals. And I think he actually does something fairly similar. There's a few differences, but he does use azure-ai-evaluation. And he's got all the built-in evaluators here. So yeah, so he's using a similar approach. So he seems to think that is that's a good approach. So I would check this out and maybe chat with Cedric. Cedric's basically like our fine-tuning expert on the advocacy team. So he might have some more thoughts based off of his experience with running these evaluations here. Okay, and then let's see. Okay, Yash asked, way back 30 minutes ago, could we also use Fabric's event streams with ML models to generate a feedback loop for the RAGChat to automate the improvements for the answers? Or is this too complicated to implement? So I actually think that maybe that's part of what they're thinking of with the A/B experiments that I just mentioned, is like, or at least like that's on the horizon. Like, once you've got everything like automated, like potentially you can have the LLM saying like, oh, like this doesn't look good. I'm going to try out a change and run that change and then see if it's better. So I think one, it is complicated to set up right now. Like even what I just set up for our repo is fairly complicated to do because there's a lot of moving parts. But two, I think that is probably the future, right? Is being able to automate improvements. LLMs tend to be pretty good at figuring out what prompt is going to work for an LLM, especially for themselves. So yeah, I think that's worth exploring, and I think it probably is the future. I think we just have to make it easier and easier, right? And we haven't done that yet. Let's see. Yeah, Barco said might be able to leverage GitHub. So for GitHub Actions, Barco suggested using GitHub models. And I did actually try that. It didn't work at the time. I forget what the technical reason was. I think they do want to make it more possible to use GitHub models in CI. Right now, it'd be a little difficult with the rate limiting, right? So remember, like, we're using up a lot of calls to LLMs here. So I actually have, like, my evaluation deployment has a capacity of 2000 TPM. And that way I can, like, send a lot of requests, in a fairly quickly and get back a response. So, you have to keep in mind, like, when you're doing evaluations, you have the LLM calls for the app itself, and then you have the LLM calls for any GPT judge that you're using. And those can add up quickly. So you need to have enough capacity for both of those. So whether you're using Azure or OpenAI or GitHub models, you would need to have enough capacity for all of those. So just keep that in mind when you're setting up, a evaluation pipeline. Is, do you have the capacity to be able to run this in a reasonable amount of time? Okay. So Paulo was asking about evaluating an AI tutor for children, which is a great question. I actually think a lot about that because I did work at Khan Academy for many years, and Khan Academy now has a tool called Khanmigo, which is both, I think it both has like a teacher facing component and a student facing component. So yeah, for teachers, for districts, for writing coach. I think they're also experimenting for programming. So yeah, so I'm very interested in that because I do still chat with the Khan Academy team a lot, and still think about this use case a lot. So I think that's a good question to, like, explore in office hours, but I'll try to, like, talk about it briefly. Yeah, for an AI tutor for children, and if you're tutoring, so that's not really necessarily a RAG use case. Maybe it is if you've got the answers, right? Like, if you know the answer to the question, like, so you want to know, like, is it correctness? But you also want to have a metric for how quickly is it revealing the solution, and is it doing doing it in, like, in a Socratic way, right? Like, a tutor usually wants to use some sort of approach where they're not just giving the solution, but they're helping the student along. And that's actually can be kind of hard with LLMs because LLMs are so trained to give the solution. They really like giving solutions. So if I was developing a an AI tutor and evaluating it, I would be looking, both at like, does it have the right answer in mind that it's leading people toward? But also, is it going at the right pace? Is it revealing things, at the kind of rate that we want to reveal things? So I think that's a really cool thing to try and figure out. But we can explore that more in office hours too. Oh, and Robbie also asks, what about evaluating multimodal or non-text language models? That's a great question. I believe that azure-ai-evaluation, I saw some people talking today about multimodal evaluation. So I believe it is supported. I haven't tried it yet. I really should. But let's see, multimodal. I think it's a different evaluator. Multimodal content filters. We can also check, do we still have this open? Evaluators. Content safety. I'm trying to see if there is one with image. Okay. Yeah, that's a good question. I think there is stuff potentially in the Azure AI SDK. Like basically, like you want to be able to, pass in images, but you could also write your own metrics, right? So it's saying like you should be able to write your own metric and do your own like GPT run. So here, like I've got my own prompts, right? So here's like my don't knownness prompt, right? So here the key is like we may need to be able to pass in an image. And I think we should be able to do it, but I haven't tested it. So I think this is kind of open question we need to figure out and have some more examples of. As far as I understand, you should be able to do it, but I think we need to figure out exactly what that looks like. Greg asks, if we want to do this with our own data, is there a repo with no training data that we can start from? Well, it depends like what you mean by, what you want to do. But from starting from, there's the notebook here that shows how to do an evaluation, and you can just, point that evaluation at anything. My RAGChat evaluator is, you can use that with things as well. So you can use the SDKs and tools with whatever. The RAG repo, it's very like the one that we show all the time. It's very easy to bring in your own data, right? You just delete what's in the data folder and then you move your own data into it and then you've got it. So it depends exactly what you mean. But that's a good lead in. Let's talk about office hours, right? So we're already way over, but I saw there were lots of questions and I'm sorry we didn't get to all of them. But I do have office hours on Thursdays in Discord. So if we didn't get to your questions, please do come to the Discord office hours, and then we can talk about them there and get deeper into stuff and maybe try some stuff out. And we also have another session this week on Wednesday, and that'll be with my colleague Anthony to talk about open telemetry and Azure Monitor and application insights and all of that stuff. So please join us on Wednesday and or come to the office hours on Thursdays with all the rest of your questions. Thank you, everyone.
Thank you all for joining, and thank you to our speakers. This session is a part of a series. To register for future shows and watch past episodes on demand, you can follow the link on the screen or in the chat. We're always looking to improve our sessions and your experience. If you have any feedback for us, we would love to hear what you have to say. You can find that link on the screen or in the chat. We'll see you at the next one.